Hi guys, in this video we are going to learn about AC circuit with capacitor based on syllabus of VTU Belagavi Karnataka. Let's begin AC circuit with capacitor considering pure capacitor C and alternating voltage source is connected across this. Let us say the alternating voltage source is P is equal to Vm sine omega t. So due to the closed path, so we expect flow of the current, that is I. Here the I, C and V can be linked together by using the formula. As you know that the instantaneous current is nothing but the rate of change of charges. Usually this Q is directly proportional to V and Q is equal to C into V, where C is called proportionality constant or it's called capacitor. Let us substitute the same value in this equation. Then I is equal to C into dV by dt, because C is a constant, V is the variable. Then C is equal to d by dt, where V is nothing but Vm sine omega t. Then this equation is equal to C, where Vm is constant, take it outside, then differentiate this sign with respect to t. So differentiation of sign is cos omega t. Here we are differentiating with respect to t, so therefore omega is constant. Let us write it. Let us rearrange this equation in this way, that is C omega Vm cos omega t. So I would like to again rearrange this equation in this fashion, that is Vm 1 divided by C omega into cos omega t. So that is equal to, we'll say this as Vm divided by Xc into cos omega t, where Xc is called reactance of capacitor, its unit is ohm. So voltage divided by resistance is nothing but the current. Therefore the equation I is equal to Im divided by cos omega t, where Im is nothing but it is Vm divided by Xc. Here I cannot compare the applied voltage and the instantaneous current because this is sin omega t and this is cos omega t. So therefore I want to convert this cos into sin with the help of trigonometric conversions. As you know that all students take coffee or all silver teacups. In this case, in the sign, in the second quadrant, sign is positive, so therefore I want to convert this equation as Im. Instead of cos omega t, I'll write that this as sin omega t plus pi by 2. The sin omega t pi by 2 is belongs to the second quadrant because here the angle is always 90 plus theta or pi by 2 theta. Sin it can be converted into cos when here the angle is odd number. If it's even, again sin becomes sin. If it's an odd number, then can be converted to another form, that is sin become cos. Then it belongs to the second quadrant. Sin is positive, so therefore I can convert this equation as I is equal to Im sin omega t pi by 2. Comparing the applied voltage, V is equal to Vm sin omega t and I is equal to Im sin omega t plus pi by 2, we can conclude that in pure capacitor, voltage lags by current by 90 degree, or we can say that in pure capacitor current leads voltage, current leads voltage by 90 degree. Let's draw the vector diagram of the same. Here the upper voltage is a reference, so therefore I want to draw like this. This is the upper voltage V, and the current is leads by 90 degree. The leading is always measured in anti-clockwise direction, so therefore the current is here. From this is a reference, so you can say that this is a 90 degree or pi by 2 radians. So the current is leads by 90 degree. The leading is usually indicated by plus sign. Okay, so this is instantaneous current I. Well, so this is all about the vector diagram. Let us draw the waveform of the voltage and current here. Okay, so along the x-axis let us consider omega t, and along the y-axis this is V. Okay, so this is the upper voltage V. Say this is V is equal to Vm sine omega t, and the current is leads by 90 degree. That means when the voltage is 0, the current is leads by 90 degree. See here, it's a maximum value what I'm getting that. So therefore let me represent this current with the broken line. Okay, well, so if I extend up to the reference axis, that is x-axis, this is what you can say is the starting point. So here from this waveforms, what you can clearly observe that I is equal to Im sine omega t plus pi by 2 radians are 90 degree. Okay, so here it's clearly indicate that the current is leads voltage by 90 degree. Okay, let us see that. Here I did the simulation with the help of multisim. Here I consider capacitor of 6.3 millifarad. Slow down the speed of simulation. I am using very low frequency, that is 2.5 Hz. You can clearly see that here the red color is indicate that upward voltage, and the blue color is indicate that the current. From this waveforms we can clearly see that the current is leads by 90 degree. Okay, the average power. The average power is calculated by using the formula P average is equal to, or one complete cycle, that is 1 divided by 2 pi 0 to 2 pi V into I d omega t. Okay, this is equal to 1 divided by 2 pi, where V is, as you know already, it is a Vm sine omega t, and I is nothing but Im cos omega t into d omega t. This is equal to, here Vm Im is constant, take it outside, then it is Vm Im divided by 2 pi integration from 0 to 2 pi sine omega t into cos omega t d omega t. Already we know that from the trigonometric formula, that is sine 2 theta is equal to 2 sine theta into cos theta. If the sine theta and cos theta is nothing but sine 2 theta divided by 2. Okay, so let us rearrange this equation with the help of this entire term. Then above equation has become Vm Im divided by 2 pi integration from 0 to 2 pi. This can be written that sine 2 omega t divided by 2 into d omega t. Okay, this is equal to Vm Im, so 2 into 2 4 pi integration of sine 2 omega t is nothing but minus cos 2 omega t divided by 2. Limits is from 0 to 2 pi. Okay, so let us substitute that limits here. Then the average power P average is equal to, it is minus Vm Im by 8 pi. Okay, so cos 2 omega t is nothing but cos 4 pi minus cos 0 after substituting the limits. Then this is equal to minus Vm Im divided by 8 pi. So cos 4 pi means the even number, so therefore it is 1. Then minus cos 0 is nothing but always 1. So therefore 1 minus 1 is equal to 0. So the average power is equal to 0. The meaning of average power is equal to 0 is nothing but the pure capacitors not consumes any power, but it stores energy. But it stores energy in the form of electrostatics. The energy stored in the capacitor can be calculated by using the formula E is equal to 1 by 2 CV square. Well, so now we'll see that voltage, current and power in waveform. Let us consider the x-axis. Along the x-axis is omega t, and along the y-axis first I will draw voltage. Okay, so this is voltage. Then next let us consider current. The current is already we know that it is leads by 90 degree. Okay, this is current I and this is voltage V. Okay, well, between 0 and pi by 2 instant, so the voltage and current both are positive, so therefore we'll get that positive lobe of the power here. Then between pi by 2 and pi, here the current is negative and voltage is positive, so therefore I'll get that negative power loads. Then between pi and 3 pi by 2, in between these two instant, voltage is negative, current is also negative, so therefore the power load is also positive because minus into minus is plus. Between 3 by 2 and pi, in this instant, current is positive, voltage is negative, and the power load is negative. Okay, so as you know that, so the average power over a full cycle is 0. At least we'll consider the half cycle between 0 and pi. In this instant, you can clearly observe that this is the positive power load and this is a negative power load. The power is scalar quantity. The average value over half cycle here, you can see that the area of these two is same, so therefore the power consumed by pure capacitor is 0 even though for half cycle. So, okay, this is all about pure capacitor. Okay, let us solve one example based on pure capacitor. A 318 microfarad, let me draw circuit diagram now. A 318 microfarad capacitor is connected across 230 volt. So this capacitor is connected across 230 volt, 50 hertz supply, 230 volt, 50 hertz supply. Determine capacitive reactance, RMS value of current, voltage and current expressions. This question carries 6 marks. Let us begin the first one, that is capacitive reactance. The formula to calculate capacitive reactance is Xc is equal to 1 divided by 2 pi Fc. Here frequency value is 50 Hz and capacitor value is 318 micro. Its answer is X is equal to 10 ohm. This is for first one, capacitive reactance. Let us calculate RMS value of the current. Here The 230 volt means it is always RMS value. If the sets are maximum, then you have to treat this as a maximum value. Otherwise, the AC is usually represented by only in terms of RMS value. So therefore, here the RMS current IRMS is equal to 230 volt divided by 10 ohm. So RMS current is 23 ampere. This zero get cancelled. So 23 ampere. Okay. Then what they are asking? The voltage and current expression. Okay, then let us say V is equal to Vm sine omega t. This is the upward voltage. I want to write in terms of the equation. Here Vm is the maximum value, 230 volt is the RMS value. We know that the formula Vrms is equal to Vm divided by root 2. That means Vm is equal to root 2 into Vrms. So here the RMS value is 230 volt. Its answer is 325.27. So therefore the voltage expression is 325.27. that is V maximum. Then what by omega? As you know that already the omega is 2 pi f. Okay, 2 pi into f is 50 hertz. The omega value is 314.16. Then so from these equations we can say sine where omega is 314.160. This is all about voltage expression. Then let us say about the current, that is I is equal to Im sine omega t plus pi by 2. Why pi by 2? Because we know that in pure capacitor the current is always leads by 90 degree. So therefore here Im is nothing but root 2 into 23 sine, already omega t is calculated, that is 314.160 plus pi by 2. Finally the current equation is I is equal to 32 root 2 into 23 is nothing but 32.53 sine into bracket 314.160 plus pi by 2. This is all about current. Okay. So what they are asking? They are asking us to calculate capacitive reactance, that is 10 ohm. RMS value of current is 23. Voltage expression is 325.27 sine omega t, and current is I is equal to 32.53 sine 314.160 plus 5 by 2. Thank you for watching.